I just can't decide. Should I play a round of golf today? Well, let's use this decision tree to make the decision. So first off, do I have the time? If I don't, well, then that's an easy decision. No golf. But let's say I do. Second decision point, is it sunny today? If there's sun, then I don't care about any other factor, playing golf. If there's no sun, let's go down to the next level. Well, do I have my clubs with me? Do I have them handy? If I do not, then I'm not going to bother playing if it's not sunny. If I do, then I absolutely will. The decision tree here is an example of a classification problem where the class labels are golf, yes, and golf, no. And while they're helpful, decision trees, they can, though, be prone to problems, things like bias and overfitting. But that is where something called random forest comes into play. Random forest is a type of machine learning model that uses an ensemble of decision trees to make its predictions. And why do we call it random forest? Well, the reason is because it's actually built by taking a random sample of my data and then building an ongoing series of decision trees on those subsets. So we're essentially creating a whole bunch of decision trees together. And those give us a larger model or group. Look, the chances are that other people have built different and maybe better decision trees to answer the same question. Maybe those trees consider things like the time of day, which I didn't consider, or the difficulty of the course. The more decision trees that I use with different criteria, the better my random forest will perform, because it's essentially increasing my prediction accuracy. And if one or two of these smaller decision trees are not relevant on a certain day, well, we just ignore them. One of the primary benefits of random forest is that it can help reduce overfitting. And this occurs when your model starts to memorize the data rather than trying to generalize for making predictions on future data. Essentially, it helps me get around the limitations of my data, which might not be fully representative of all golfers or all the best features in my model. It can also help reduce something else, and that's bias. Bias can occur when there is a certain degree of error introduced into the model. Bias occurs when you're not evenly splitting your instance space during training. So instead of seeing all of the data points, you might see only half because of how you set your model up. Now, to set up a random forest, you will set some parameters. We have parameters for node size. We have parameters for number of trees. And we also have parameters for number of features. And it can be challenging at first because you'll want to use a lot of trees, like as many as you can, to get the best predictive accuracy, but you don't want so many trees that it'll take you a long time to train the model and use a lot of memory space. But once you've set up these parameters, you'll use a random forest model to make predictions on your test data, and you can even segment or slice your results by different criteria. Maybe you want to know how your random forest does on certain types of golf courses or how it performs during different times of day. Random forest is pretty popular among data science professionals, and with good reason. It can be extremely helpful in all sorts of classification problems. In finance, for example, it can be used to predict the likelihood of a default. In a medical diagnosis, it can be used to predict prognosis or survival rates depending on treatment options. And in economics, it can be used to sort of help understand whether a policy is effective or ineffective. So what do you think? Should I play golf today? Well, the sum of all my random forest decision trees say yes. I'll see you out on the course.
If you have any questions, please drop us a line below, and if you want to see more videos like this in the future, please like and subscribe. Thanks for watching.